And here's the rough outline of what a tapeworm looks like. You can see the scolex at the top. Like I said, it's not a true head, but think of it as such. Those hooklets and suckers are what they use to attach to the intestinal wall. You don't need to know this term. The entire body of the tapeworm is called the stroblia. And each one of these segments is called a proglotid. They have male and female reproductive parts, and these are the ovaries full of eggs. You may find a proglotid. You may find a section of 5, 6, 7 proglottids. We can diagnose which tapeworm we're dealing with based on the shape and appearance of the scolex, and also based on this proglottid, because the different species have a different arrangement and number of branches of these ovaries. What's that?
Do you usually just have one in your body?
You can have multiple tapeworms, but you're gonna go downhill really quick with more than one. Here's an actual photo of what a tapeworm is. You can see the size difference between the scolex and the proglottids. That is the scolex. I mean, the scolex is really, really small. And these are the proglottids. And you can see the farther down you go, the more mature the proglottids are until they eventually break off. You will not ever find the scolex unless they give medication to kill it, because it's attached to the mucosal wall. It's not coming off. Yes?
When the mature proglottids do break off, do they themselves develop their own scolex?
No. But what they'll do is they'll basically explode, releasing hundreds upon hundreds of eggs, which will each then produce their own scolex. We're going to talk about 5 different ones. Hymenalepsis nana, the dwarf tapeworm. Dwarf is a little bit of a misnomer because we're still talking about a 10-foot worm. Taenia saginata, the beef tapeworm. Taenia solium, the pork. Echinococcus granulosus, dog tapeworm. And probably the most common worldwide, Diphyllobothrium latum, the broadfish tapeworm. Hymenalepsis nana is the most common in the U.S. This is the dwarf tapeworm. This one does not require an intermediate host. It will often use the common house mouse as an intermediate host. So how do humans get this? If you get a mouse in your house, they're going to run all over. They're going to poop on stuff. You're going to eat it. You're going to touch your countertop. You're going to touch your mouth. Accidental ingestion. In the egg, if you look very closely, and it is very difficult to see, you can sometimes see these hooklets that's going to be on the scolex in the egg. And you can see on this, I mean, they're in there. You have to look very closely. It's hard to see. The egg on this one has 2 polar knobs with filaments on it. Looks like flagella. It's really not. Think of it as hairs. I mean, the egg can't swim around. This one can be anywhere from 2 to 10 feet long. So anywhere, there to the length of that table and more. Transmission is by eating the egg. Diagnosis on this one is by finding the egg in the stool. And like most of these parasites, very few hospitals have a parasitology department. We're going to find this by accident. We're going to be looking at stool for white cells or things like that, and we're going to come across this and go, whoa, wait a minute. So that's why we have to be aware of this. These next ones are my personal favorites. The Taenias. Taenia saginata, Taenia solium. Completely indistinguishable by egg. Eggs are the same. They have the thick, brownish, yellowish wall, radial striations, wagon wheel appearance. And these are a little bit larger, and it's a little bit easier to see the hooklets. You can see it pretty well in that egg. Humans are entirely an accidental host. These are the beef and the pork tapeworm because that's where they want to end up. We get it by eating usually undercooked beef or pork. The problem with these is people used to take tapeworms as weight loss. These two in particular, you'll lose massive amounts of weight, but these eggs can insist in any organ of the body, including the central nervous system.
Your brain.
These insist in the spinal column of the brain, and they are rapidly fatal. If they stay in the intestinal tract, it's Jenny Craig. So these are indistinguishable by the eggs. So how are we going to tell them apart? By the proglottids and by the scolex. You can see the solium, which is the pork. It retains its hooklets. It buries those into the intestinal wall, as well as using these rows of suckers to attach. Sagonata will shed those hooklets. It's much flatter, broader, and it relies strictly on the suckers to attach. The proglottids, the uterus, the orientation of the uterus. Solium only has between 7 and 12 branches, and this one has 15 to 30. Much finer, much more branches to the uterus. Solium, the slang term for it is the armed tapeworm, because it still has that crown of, looks like a crown of swords at the top. So solium retains its hooklets. The other one, just for giggles, is the broadfish one, and you can see the scolex on it is completely different. It only weakly attaches. It has a little slit that kind of acts as a sucker, but that one you can like grab it and pull it out. You grab this and pull it out, and you're going to prolapse somebody. Actual photos of the two. And again, you're usually not going to see the scolex. If they've diagnosed them with a tapeworm and give them medication to kill it, it's going to let loose and come out in the stool, and you may find it then. But as a living tapeworm, these are not coming off. These you very well may see. These can be shed in stool. Like I said, as little as one proglottid, it could be a segment this long of proglottids. So eggs or proglottids are what we're relying on to see these. The beef tapeworm, Pania sagonata, relatively common in the United States, especially the southwestern part of the United States. That's kind of the same endemic range as bubonic plague, Arizona, New Mexico, West Texas, that area. Heavy beef eating regions. And beef tapeworm makes sense. Pork tapeworm, very, very rare. Very rare in the U.S. Almost never see this one. Does occur, but very rare. I think in the U.S. we've learned our lesson on undercooked pork, so we don't have too much issue with the pork tapeworm. Diphyllobothrium latum, the broadfish tapeworm. This egg is a little bit different than what we talked about before. This is the first egg we've talked about that is percolated. A percolated egg. Think of that as a lid to let the larvae out. It's a weakened area where it'll pop open right there like a lid to get out. Oddly enough, chickens do about the same thing. When chicks are hatching, they peck around the inside of the egg and weaken it, and it pops open like a lid if you've ever watched chicks hatch. But that isn't a percolator. This one has a little terminal knob on the bottom. Sometimes hard to see, depending on which way that egg is turned when you're looking at it on the microscope. But sometimes you can see this operculum, and you can see it here. It is very faint. You've really got to play with the focus in and out to see that operculum. This tapeworm can be up to 20 meters long, 60 feet. The main symptoms from broadfish tapeworm is from B12 deficiency. This tapeworm loves vitamin B12. It can absorb up to 100% of your nutritional intake of B12. So even if your diet is on point and you've got one of these, your body is getting 0 B12. The worm takes it all. Fairly common in the United States, especially in the Great Lakes region and in Alaska. This is found in most freshwater around the world. Comes from eating fish that maybe wasn't quite cooked long enough, a little undercooked. Sushi, of course. In the Baltic region of Europe, we're talking Germany, Poland, Denmark, and all that, they estimate 100% of the population may be affected with this. That's how prevalent it is there. Most mammals that consume fish can serve as a host to this. Bears, even dolphins, whales that swim up rivers to feed, they can get this. Echinococcus granulus, the hydatid tapeworm. They call it the hydatid sand tapeworm because when you see the egg, it is very sandy looking. It looks like an egg full of sand. It's gritty looking. This is another one where strictly an accidental host. The downside of this, it will form these large cysts, usually in the liver. Develops very, very slowly. It is usually non-symptomatic until it's fairly progressed. And by the time it gets to that point, it is often fatal. Unless you start showing symptoms and they pop this up and see it on CT or something and get it out of there, you're going to have major issues.
What would be like the onset of symptoms if you did get them before?
Abdominal pain, usually indistinct abdominal pain. The downside to this is if they do not catch it quick enough and one of these cysts ruptures, death occurs rapidly due to anaphylactic shock. How humans get this? This is primarily found in sheep. We get it, the farmers get it from their sheepdogs. The dogs are around the sheep all day. Dog comes up licking on the owner, petting on him. You know, a lot of times they live in the home. I mean, those are family friends. Those are co-workers, not pets. But that's how humans tend to pick it up. They tend to pick it up from their sheepdogs who got it from the sheep themselves. But these ones I like a little bit more. The flatworms, the trematodes, called the flukes. They're flattened, dorso-ventrally, non-segmented leaf shape. That's a fancy way of saying they look like a leaf. They're very, very thin. They're very much flattened. They have a very simple digestive system. There are two types. The hermaphroditic ones are the intestinal or tissue flukes. The other ones, the blood flukes, they are unisexual. There is male and female in the blood flukes. The other ones are hermaphroditic. Complex life cycle involving snails. You'd think, as complex as this is when we show it, that we should never get this, but it does happen. Humans are the definitive host with these. First one, Fasciolopsis buski, the large intestinal fluke. Fasciola hepatica, the sheep liver fluke. These two eggs are completely indistinguishable. Very large egg, very weak, indistinct operculum at the very, very end of the egg. Diagnosis on these, usually based on symptoms. Fasciolopsis buski usually starts with bowel ulcers, mucoid diarrhea, intestinal obstruction. The other, hepatomegaly, bile duct obstructions, and jaundice, intestinal versus liver. So once we see the egg and we know we're dealing with one of these two, then they'll use symptoms to diagnose which one it is. These two are transmitted by eating uncooked or undercooked water plants. Unfortunately, the most common one is one of my personal favorites, water chestnuts. I love those things, even though they're almost tasteless. That's the most common way to get these. So how these are transmitted, mention the complex life cycle involving snails. A human or an animal gets it, defecates, somehow that feces ends up in the water. The eggs come out of the stool and are eaten by snails. The larva then leaves the snails and swims around and deposits on the plants, whether it be water chestnuts, what else is water grown? Cranberries, things of that nature. Rice in some instances. And then we consume the plant, we get the egg, cycle starts all over again. Next one is a personal favorite of Carol Spargo's. She loved this bug. Clonorchus sinensis. She always said this looks like a mouse. I don't see that. Very unique looking egg though. Has a very prominent polar knob, very broad shoulders around a domed operculum. I mean, you can see the shoulders even in the actual egg, not the diagram. Diagrams are always rude. It has the bubble on the end, the domed operculum, and the broad shoulders. This one comes from undercooked fish. It's called the Chinese liver fluke. That is typically where it is found. It is found in China and in the Far East. It is a liver fluke, so liver symptoms. Bile duct obstruction, jaundice, enlarged liver, things of that nature. The reservoir host for this is dogs and cats. Dogs and cats get it, poop in the water, snails eat it, the cycle comes around, we end up with it. Through the fish this time. Paragonymous westermani, oriental lung fluke. Very flattened end, very flat operculum on this one. Does have distinct shoulders, usually. That picture, not so much. You can see a little bit of a shoulder there. No polar knob, but the shell is usually thickened on this bottom end. Notice the egg is very similar to that of the broadfish tapeworm. It's a little bit flatter on that end. It has a little bit of a shoulder, and that's how you can tell it apart. This one comes from undercooked crabs and crayfish. This is a lung fluke, lung symptoms. Chest pain, cough, bloody sputum. The immature flukes, when they're first hatched, they're babies. They don't know where they're going. They don't know they belong in the lungs. In a roundabout way, they don't belong anywhere, but they don't know they're supposed to go to the lungs. They may swim to the brain. They may swim to the liver and insist there. And as a result, symptoms can be widespread. It can also be rapidly fatal if these end up in the brain and cause a big cyst in there. So think of these, the babies on this one are notorious for getting lost and just wandering wherever throughout the body. They can insist in your thigh. On x-ray for this, it will look like the patient has TB. The scarring, the disfigurement of TB on x-ray is what this looks like from the damage it does to the lungs. You will often see doctors order stools, like they're doing an open parasite, they'll order it ×3. Some of these organisms pass their eggs intermittently. This is one of them. You may do an open parasite exam on the stool and it's negative. You do one tomorrow and it's positive. And that's why a lot of times you'll see these tests ordered O&P ×3. They'll do an O&P every morning for 3 days. Because some of these worms, they only shed eggs just every so often, so it's very, very easy to miss. And if you're ever wondering, why do we have to do this 3 times? This organism is one of the reasons. Here's actual photos of the adults, which are usually not going to see if we diagnose based on eggs, but just for giggles, this is what they look like. This one, the biggest one, is between 2 and 7 centimeters. I mean, that's that long. You don't need a microscope to see this if you find an adult. And we've actually got one of these on the slide, and we're going to look at it Thursday in the lab. I mean, you can see it on the slide. I mean, we can't see these internal structures without the microscope, but it's large. The eggs, of course, are microscopic. Blood flukes. These are the ones that were unisexual. There are males and females. No, we cannot tell the males from the females, but we can tell them apart based on species. Schistosoma mansoni is found in Africa, Central and South America. Japonium, think Japan, found in the Far East. Schistosoma hematobium, Africa and the Middle East primarily. The first two we diagnosed by eggs and feces. This one you can actually find the eggs in the urine. So again, if one of them is found in the Far East, one of them is found in Africa and the Middle East, none of these are in Arkansas. People don't stay in Arkansas. People travel.
Right.
As far as the one that's found in the Middle East, we got a whole lot of soldiers in the Middle East right now. Central and South America, we have a large Hispanic population. They have families. They go visit. They come back. So, I mean, finding these is not unheard of. It's just rare. You'll love the next picture.
Oh.
The life cycle. What can I say? Poop ends up in the water, the egg hatches, gets in the snail. The snail releases basically the larval stage called the cercaria. You don't need to drink the water or anything. These can penetrate the skin. You just got to go swimming. So if you're swimming in contaminated water, you could pick this up. Of course, everything will take the route of least resistance. So if you get water up your nose or in your mouth, that's the route they're going to take, but they can go straight through the skin.
Was he pooping in a
So
tree?
again, it's another one, weird life cycle involving snails. Without the snail, this life cycle doesn't persist.
It's not American, man.
So Mansoni, Africa, South and Central America. This will be the one you're most likely to find. Very prominent spike on the side of the egg. Large lateral spine. The one in the middle, hematobium, that's Africa and the Middle East. This is the one we're looking for in the urine. It has a large spine as well, but it's terminally located. It's on the end. Japonium does have a lateral spine. It is very small, very indistinct, and even blown up on this, I can't see it. Should be right there. But you can tell the difference between this and that.
Mm-hmm.
If you can see the spine on Japonium, it is very, very small, very indistinct. It barely protrudes the wall. This one very obvious, this one very obvious. So all of these have similar symptoms. These are swimming around in your blood. They cause typhoid-like symptoms. Fever, cough, enlarged spleen and liver. That will lead to, if untreated, cirrhosis, bloody diarrhea, and bowel obstruction. Granulomas form around the eggs in the body. Your body does not like this. It tries to wall it off. As a result, you end up with large granulomas wherever the eggs happen to be found. Liver, urinary bladder, gallbladder, intestines. And that is what's causing the bowel obstruction usually. These granulomas are forming and walling this off, and they can actually obstruct the bowels. Worldwide, it's estimated 200 million people are infected with these three. 800,000 die a year from the schistosomas. So your odds of seeing this in a lab are fairly good. Again, unless you work in a lab that has parasitology, you're going to find this by accident. But the key is to zoom in on this when you see it. Because the quicker we can find this, quicker we get them treated, you know, it's better for everyone. Even if you see it by accident.
So Becky, if she sees that, she's gonna send that out?
Yeah. We see this, we're sending it out. Because this is one of those things. Remember we talked about the API surveys and the CAP surveys we do in the lab?
Mm-hmm.
Every test we offer, we have to be tested on to make sure we know what we're doing. We don't do CAP surveys on parasites. So we see one, we've got to send it out. We are not allowed to diagnose it. But when we send this out to LabCorp Quest or whoever, we're gonna tell them on the phone or whatever, it's like, look, they got schistosoma. It's a positive. I'll tell you right now, it's a positive. You just gotta confirm.
And she said call her, by the way, I'm sorry.
She always wants something.
I know it.
And even though we're diagnosing this based on age, you're almost never gonna see the actual schistosoma. Here's what they look like.
Dang.
We're talking about worms. They're worms. They're flat, but they're worms. 40 microns is the scale on that, so you can see they're decent sized worms. It's all of number 2. But remember, we had 2 legs. Again, we're going to go over this again on Thursday when we review. Don't get too carried away. Protozoa. We're talking about protozoa. Most of these are going to reproduce by binary fission. Fancy way of saying mitosis. They squeeze into one becomes 2. It divides. There are approximately 30 species that parasitize humans worldwide. 2 major routes of infection is either ingestion of the eggs, most commonly through the bite of some sort of arthropod or fly. So the first one we're going to look at are protozoa that move by pseudopodia. We're talking about amoebas. Y'all know what amoebas are. They're balls of snot that ooze around your body. The little oozes, those are called pseudopodia. It's like legs. Entamoeba histolytica, Entamoeba hartmanni, coli, Endolimax nana, and Iotamoeba bushleyi. I like that one just because I like that name. To differentiate these, there is a chart on page 78 of your book that will help out a little bit as we go through them. Entamoeba histolytica. Most of you have heard of amoebic dysentery caused by amoeba. This is your cause. Chronic infection with these may last for years. You're going to identify these based on ingested red cells in the troph form. These organisms have 2 forms, troph and cyst. Cyst, you know what a cyst is. It's walled off doing nothing. The troph form is the motile form moving around. This one lives by eating our red blood cells. So if you see an amoeba with intact red blood cells in it, this is your culprit. It's the only one it can be, and that's how we diagnose it. The cyst form can have 1, 2, or 4 nuclei with a central karyosome. A karyosome, what it is just a clump of nuclear DNA. It's a dot. It's a little black dot in it. Could also have a large cigar-shaped chromatid body. Chromatid body is condensed RNA. You'll see the picture. It is very rod-like. So here's what it looks like. The first one, you don't see any ingested red cells. You see a couple of spots where maybe one's starting to be digested. This one, you can see the red cells in it. You can see the centrally located karyosome, dead center of that nucleus. In the far right, you see the chromatid body. This is that condensed RNA, rod-shaped, cigar-shaped. And you can see on this one, you can have 1, 2, or 4 nuclei. 1, 2, 3, and indistinct one right there, probably 4. So ingested red cells, remember that. When you see an amoeba with ingested red cells, it is Entamoeba histolytica. That is our pathogen that we're going to talk about. Entamoeba hartmanni, very similar. Virtually identical in appearance, except for one distinguishing characteristic. This one does not eat red cells. It is very so slightly smaller. You can't tell that by looking at it. Some of your pathologist microscopes, or if you have a parasitology department, they actually have microscopes that have a ocular micrometer in them, so that you can use it to measure stuff in the microscope. And then you could maybe measure the size and determine whether it's smaller or larger. By the eye, you're not going to be able to tell. You're going to have to rely on seeing ingested red cells. And here you can see the difference. It has the cigar-shaped chromatid body. It has the centrally located karyosome. It looks virtually identical, but there are no red cells in this. You don't want to call this one because it is not a parasite, it's commensal. Y'all remember what the term commensal means?
Where it benefits, but like you don't benefit, but it doesn't harm you either.
Exactly, perfect. It benefits, it's living in our body, absorbing our nutrients, but it's not doing any harm to us. There's no reason to treat it. If you had one of the microscopes with the micrometer in it, these will be 10 microns or less, and the histolytica will be between 10 and 20 microns. So it's smaller, but other than that, virtually identical. Again, rely on seeing ingested red cells. The histolytica is a voracious eater. It eats a lot of red blood cells. You're more often going to find them full of red cells than not. So if you don't see red cells, assume that's not a pathogen. Entamoeba coli, very similar, except the karyosome in the nuclei is not going to be in the center. It's eccentric. It's off to one side. The chromatid body is not cigar shaped. It looks like it's shattered. It looks like shards of glass in it. This one will eat bacteria. It will have ingested bacteria commonly, but will not ingest red cells. So you can see on the trope, that karyosome is nowhere near the center. So we know automatically this is non-pathogenic. It's not the one we care about. There's no ingested red cells. It does look like it ate a big cocci right there, though, so maybe it's eating staph, so maybe it's helping more than we think. The chromatid bodies. This is actually them right here, very faint and indistinct, because it's not that large cigar shape. It looks like needles, like shattered needles. Endolimax nana is another one. The karyosome is irregular. There is no chromatid body. There's no ingested red cells. You can see this. It's way off to one side. It looks almost completely black. This one doesn't even have a dot. It's just a completely irregular karyosome. It's not condensed at all. No chromatid body at all. Looking at this, it looks like a blob of trash. If you're looking at a stool and you see that, that doesn't really look like an egg. It just looks like garbage. But it's a little bit too perfect. It's a little bit too smooth if you were to see that cyst. Now, in the troph, it's a little bit easier to see that nucleus. But on the cyst, it's very indistinct because of that thick wall. But like I said, it's a little bit too perfect to be just like some dietary garbage coming out in the stool. Amoeba bushleyi. Only one nucleus in the cyst, large irregular karyosome like the last one. This one's unique in that the cyst often, I would like to say always, I've never seen one without it, often has a large glycogen vacuole. It likes to steal our glycogen from us. Does not ingest red cells.
So if I got that, would it help with my diabetes?
I don't know. Might be worth a shot.
That's what I was about to say.
And this is a large glycogen vacuole. Now, we're looking at stools, we're usually going to stain it, correct? Well, if we run it through a right stainer, or even through a gram stain process, this glycogen is going to stain. If we gram stain this, it's going to absorb that iodine, and it's going to be a big brown circle in it. And that's usually the way I've seen it. It's a big brown glycogen vacuole. If you run it through a right stainer, it's going to absorb that eosin, and it's going to be red looking, like an eosinophil. but very, very distinct. And again, another commensal. So if all these are commensal except for that one, why do we talk about it? Because we need to be able to tell them apart. Because this one needs treatment. The rest of them do not. We don't want to call someone to get treated when they don't need it. So we're trying to differentiate all of those that don't matter from this guy. So again, if you see ingested red blood cells, burn that into your brain. That patient needs treatment. That is a parasite, pathogenic parasite. And rely on seeing those ingested red cells. Again, they are voracious eaters. They constantly eat red cells. And if it's eating red cells and destroying red cells and then releasing the trash back in the body, what's one of the first symptoms you're likely to see in the patient?
What, like fever?
Anemia?
Not necessarily. Something you'll see before anemia even.
Oh.
What happens when you destroy red cells?
Is it bilirubin's released or whatever it is? What is it?
You're saying it.
Bilirubin's released?
Bilirubin's going to go up.
Yeah.
Destruction of red cells in the body causes increased bilirubin. They're going to have slightly increased bilirubin. It's going to be the first symptom before they even feel anything. They're going to have their bilirubin is going to start creeping up. Flagellated protozoa. Just what it sounds like. They move by flagella. They swim very, very fast. Giardia lamblia, Dientamoeba fragilis, those are GI pathogens. Chylomastix mesnili and Trichomonas hominis are GI non-pathogens. This is the one you're going to get sick of seeing in the lab. Trichomonas vaginalis. Sexually transmitted protozoa. Trypanosomas, Rhodients, Gambients, and Cruzi, and the Leishmania species. These inhabit the GI tract, the atria, the bloodstream, or tissues of humans. Atria, does everybody know what atria means?
Wait, your
The
heart?
word actually means an opening.
Yeah.
In the human body, the atria refers to the mouth, the urethra, and the vagina.
Oh.
Giardia lamblia, giardiasis, also called traveler's diarrhea. There's a problem with that, because what else have we talked about? They call traveler's diarrhea. Remember Montezuma's Revenge?
Yeah.
Caused by enterotoxigenic E. coli. Same name, different cause. Very, very distinct appearance. 2 nuclei. Shirley Fargo used to always say it looks like an old woman with glasses. You can see the 2 nuclei here. That looks like the bridge of the glasses. That almost looks like a mouth.
Must be a catfish or something.
Catfish?
I can get that.
I can get that. This one is also called beaver fever. That is primarily how it is spread, by beavers. The beavers are the reservoir hosts. They contaminate the water supply. We pick it up that way. Something that I like here that has a unique name. This causes abdominal pain and extremely foul-smelling diarrhea and horrific deadly gas. The horrific deadly gas has a special name. It's called the purple burps. Just FYI. This one inhabits the GI tract. Traveler's diarrhea. You're thinking dysentery-like almost, extreme diarrhea, often bloody. Why is it causing that? This is an electron microscope shot of the intestinal wall. It will completely coat the intestinal wall. Your body can absorb nothing. Everything that goes in passes out the other side. The only thing that gets absorbed is whatever these giardia eat. That's where the diarrhea comes from. Your body can't absorb anything. Because when you get infected with this, it's usually in heavy enough amounts that these giardia tropes will coat the entire intestinal tract. So again, everything that goes in is going to come out the other side at a rapid rate of speed. This is the one that I found at National Park. Patient had been coming in for 3 to 4 years with diarrhea, never could diagnose it, and they had me doing a fecal smear looking for white cells, which is indicative of inflammation, like colitis. First thing I saw in the first field was Giardia. I started looking around and there's Giardia everywhere. And again, I can't diagnose that. What I could do is call the doctor. It's like, Doc, I'm not allowed to diagnose that the patient has Giardia, but the patient might have Giardia. Just saying. I said, you need to come look at this slide. So he came over from ER and looked, and he said, yep, that's Giardia. And he went back and treated her. I was hoping maybe since she was such a frequent flyer that we could get rid of her for a while, but no, she just found another complaint kept coming. But we solved that problem that had been going on for 2 to 3 years.
How do you treat it? How do you get them off?
There's anti-parasitic medications, and like 2 or 3 doses, these are all going to die and they're just going to come out in the store. You're just going to shed them. These are not too bad because you'll never notice those. But like a 60-foot tapeworm,
Yeah, you'll notice that.
got to come out too. So you're like, down there pulling rope.
Oh my God.
Of course, bad enough they're going to surgically remove those, but even if it's in there and you kill it, it's coming out. Luckily, these are microscopic and you don't know that they come out.
So since the doctor came over like the slide, you don't have to send it out?
We still have to send it out.
Okay.
The best part is 3 days later, LabCorp came back with a result of no parasite seen.
Oh, wow.
Becky got on the phone and cussed them up one side down the other to the bluntly. And said, you get somebody who knows what they're doing and look at that again. 3 hours later, oh yeah, that's positive for Giardia. Yeah, no kidding.
Jeez.
Trust your own eyes. Dientamoeba fragilis. There is no cyst stage of this one. These, it's another one that's in the GI tract, causes diarrhea, and you can identify it by 2 nuclei. And look at the karyosomes on this. Kind of distinct. It's almost a tetrad. It's in 4s. Most will have 2 nuclei. Occasionally you will see one, like over here. Pretty sure that one has 3. That one's pretty indistinct. But most of them have 2. This one only has 1. 90% of them are going to have 2 nuclei with that really unique karyosome appearance. This one, again, no cyst stage, usually 2 nuclei, usually asymptomatic, may cause diarrhea, usually mild diarrhea. People don't go to ER for mild diarrhea, usually. Some people do. So how are we ever going to diagnose this if it's so mild? This diarrhea, if you get it, it doesn't go away. Even if you have mild diarrhea a couple of times a day and this lasts for 6 months, eventually you're going to go to the doctor. And that's when you're going to start picking this one up because it's not very severe. It's not life-threatening at all. Could be found, this one is found worldwide, not terribly uncommon, but terribly undiagnosed because it is so mild. This is not something that's going to put you in ER quick like some people will. Yes?
To diagnose, you're just going to do fecal smears?
Yep. If you're sending it out for O&P, you're going to put some of the stool in one of these and send it out. And they're actually going to spin it, concentrate it, and make smears on that. Again, most labs, you're going to find this by accident. When you're doing fecal smears, like we did a lot of fecal white smears, just smearing a slide and right staining it, looking for white cells. And that's how you're going to find it most of the time. Because there's no one local who does their own parasites. In Little Rock, they do some. So, this is the one you're going to get sick of because you're going to see this at least once a week. In the summertime, you're going to see it 5 to 6 times a day. It likes warm weather. Trichomonas vaginalis. This one has no cyst stage. When you see it, you're often going to see it in a urine or in a vaginal wet prep, and it is going to be very mobile. It's going to be dancing around everywhere. It has usually 4 flagella. They're usually not pretty and straight like that. They're more like that. They're curled up and they're whipping like this, and that's how it's moving. It has an undulating membrane down its back, and you can see it wiggling. This labeled AX is the axo style, and think of that like a support rod. Doesn't really matter to us except for one thing we're going to talk about in a second. You got to pay attention to. But notice this undulating membrane, it stops about halfway. This is the one that is sexually transmitted. Men will be asymptomatic. In women, it will cause itching, burning, and foul-smelling discharge. You will diagnose in vaginal and urine specimens. In the summertime in Arkansas, you're going to see this a lot. Cannot be confused with Trichomonas hominis, which looks very similar. We're going to talk about that shortly. And on this one, do not misdiagnose this. And we'll come back to that. Look at the Trichomonas hominis on the right. Complete non-pathogen. Found in most people's GI tract. The undulating membrane comes all the way to the end and it has a flagella coming off of it. The rest of it looks very, very similar. So if you see this in a patient and you call it Trichomonas vaginalis, you're telling that patient they have an STD. The reason to not misdiagnose that, you think about it, you just told a patient they have an STD when they don't. If they're in a relationship and they know they haven't cheated and they've got an STD, that means their partner did. You could ruin a marriage by misdiagnosing this. Pay attention to what you're looking at. Make sure you're right when you call it. And trust me, you're going to see Trichomonas vaginalis so much, you're going to get good at it. But do not confuse it with this. Look at the undulating membrane. Look at the flagella off the end. This flagella will move.
So will it always have a little bitty notches on it?
Usually, yeah. Just because it's rippled, and that's why it looks like that. This axo style, and you can see it looks a little bit like a flagella. That is a rigid support rod. It does not move. It will stick out there and not move at all, if you even see it. That Trichomonas hominis, that's an actual flagella, and it's doing this. If it moves, it's hominis. It's not vaginalis. The reason you see this much more often in the summer months, by the way, I mean, this has got to be kept moist and warm to live, obviously. In men, it tends to live right in the end of the urethra or under the foreskin. In the winter months, extremities are just too cool for this. In the summer months, it can live there for days on end. It's kept nice and warm and sweaty, just like it likes. And that's why you're going to see this a lot more in the summer. You're still going to see it in December, January. You're going to see it every day in July and August. It's that common, unfortunately. And why is it that common? Because non-symptomatic in men, they don't know they got it, so they like to share the love. Hemoflagellates. Hemo, blood. These multiply in the blood. Trypanosoma brucei rhodiense, East African sleeping sickness. Most of y'all have probably heard of sleeping sickness. Trypanosoma gambiense is West African sleeping sickness. Trypanosoma cruzi causes Chagas disease. I know you've heard of that one. That one's common enough in America that every unit of blood donated is tested for that. These cannot be differentiated in the blood smear. When you see it in the blood smear, these are red blood cells. You know what this looks like on a dip, and look how large they are. You're not going to miss this. They're usually C or S shaped. It's literally worms in the blood. They're not hard to see. Both of these are the two sleeping sicknesses. They are spread by the tsetse fly. Fly bites someone with it. It multiplies in the fly, usually in the fly's mid gut. They bite the next person, spread it. Uh, Diagnosis for this is you seeing the worms in the blood, obviously. Symptoms: fever, headache, night sweats. Based on that, I may have it. Central nervous system changes, lethargy, coma, and death.
Wow.
It's called sleeping sickness because of those last couple. Cause lethargy, they don't want to move, they sleep all day, and eventually go into a coma and die. And that is why it's called sleeping sickness. The difference between these two, Gambians, you'll take 6 months or a year to go through that entire cycle to cause death. Rodents can cause death in as little as 30 days from infection. Other than that, they're virtually identical. These cannot be distinguished even in parasitology labs without extensive molecular testing DNA. Because look at that, these are the exact same species. They're different subspecies. They are identical in every way except for some molecular differences. So we're not going to tell these apart. But if you see worms in the blood, I hope that raises some red flags for you. This one you very well may see in the United States.
Kissing.
Very likely. Chagas disease. There's a reason Arkansas Blood Institute tests all of our blood for this. It's not terribly uncommon. You can see, again, you see it on a blood smear, you can see that worm. And you're not going to see one. I mean, there's going to be dozens of them as you look through the smear. There's another one right there just on this picture. This one is spread by the reduvid bug, or the reduvid beetle. Usually causes a sore right over here. For some reason, it likes to feed by the eye. It always bites right here. How it gives it to you is that when it bites and drinks the blood and causes that little wound,
Poops.
it then poops in it to plug the hole and kicks it down in the hole.
Why ain't they a little dirty hole?
They plug the hole with bug food. That is how we get it. The bug bites, defecates into the wound, the cysts invade, and they will head to the central nervous system, the liver, and the heart muscle. They will then insist in those tissues, shedding eggs into the bloodstream for this, waiting for the next reduvid beetle to come by and pick it up and share the love of your neighbor. In children and the elderly especially, it can cause rapid death due to weakening of the heart tissue. You have these cysts in the heart muscle, and that's just weakening that. And then our most susceptible being children, the elderly, people with underlying heart issues, this can be rapidly fatal. As far as the reason our blood is tested for this is because they get positives frequently in Texas now. From Texas to California, they get a lot of positives. We haven't seen a whole lot in Arkansas yet, but it's coming. I mean, it's right there. It's 100 miles away. All right, so I want you to look at these worms, the trypanosome. S-shaped, they don't really have a distinct flagella. It just looks like an extension of the tail. All these trypanosomes look about the same. Leishmaniasis is a little bit different. It's another worm, you're going to see it in the blood, but look at the flagella coming off the back. It's about the same size, but they have a little bit different structure, a little bit different appearance. These are spread by the sandfly. And again, found in Central America and Texas. It's not far away. This will usually cause, the sandfly will bite, will cause a large pus-filled blister. If someone is with it enough and they go to the doctor and doctor aspirates that blister, it is full of these. That's an easy diagnosis. How many of y'all go to the doctor for a blister?
Nope.
Nobody does, and that's the problem. We're not going to see it until it gets to this stage and it's swimming around in the blood. Usually causes fever, chills, diarrhea. If untreated, 95% mortality rate. This one likes to invade the bone marrow. Weird, I know. It invades the bone marrow, sheds to the blood. So all of these cysts and what they call the amastogotes, the Leishman-Donovan bodies, are invading the bone marrow. This is going to cause some strange anemias, almost leukemia-like appearance, because bone marrow is messed up. So when they go in and do a bone marrow aspiration, and you make slides, and the pathologist starts looking at them, he might see these. We're not, because we don't look at bone marrow smears in the main lab. We're going to see this. But those Leishman-Donovan bodies is what they call as the encysted form in the bone marrow. The pathologist very well may see those. And when you start invading the bone marrow, you start affecting how we produce blood and how much blood we produce. You can see why it's rapidly fatal. It's fatal due to completely uncontrolled anemia. You're losing platelets, white cells, red cells. It's not just anemia, you're out of everything because your bone marrow is not doing its job anymore thanks to these bugs. Yeah?
Pancytopenia?
Pancytopenia, good. We're going to look one more before we take a break. Valentinium coli. This is the only pathogenic ciliate in humans. What is a ciliate? Their whole body is covered with cilia. It's covered with hairs. You can see it. Usually, they're so small you really can't see movement, but you can see a shimmer of motion right around the outside wall. And you'll see it all the way around, and you know that's a ciliate. If you see a ciliate in a human, that's pathogen, and it's got to be this. That's the only one we get. If you can see the cyst, you can see a large cigar-shaped macronucleus, but you're not going to see cysts usually. You're going to see the motile trophoforms, and you're going to see those cilia. And you can see just how many cilia they have based on the electron microscope. This one will invade the intestinal mucosa. It actually burrows into the mucosa of the intestine and causes dysentery like so many others. So again, when you start getting dysentery, a lot of diarrhea, doctors like to order fecal white blood cells. You make a smear on the slide. You find this stuff by accident most of the time. Just be aware when you're looking that like, that is not normal. We need to dig farther. Be willing to take that step. All right, y'all take 15 and we will come back and talk about malaria. That's great. I'm making this up.
I think so. I hope so.
All right, sporozoans. Starting with plasmodium. You see the word plasmodium, you think malaria. That is what causes malaria. We've all heard of that. Babesia. Totally different disease. Looks a lot like malaria. Also endemic in Arkansas. Toxoplasma gondii. We'll cover that, and you'll learn that that's what you get from the nasty cats. Cryptosporidium parvum and Cyclospora cayetensis. All of these will produce a spore that is infected. Infected for the definitive host after it's ingested or injected by a biting arthropod vector. So all of these parasites are going to be given to us by some sort of arthropod or a bite. You can get it through ingestion, but exceedingly rare. The 4 plasmodium species, the 4 different types of malaria. We're not going to get real in-depth into this chart. The trophozoites, that's what you're most commonly going to see in a blood smear. That's the ring-formed parasite inside the red blood cells. You cannot tell these apart by looking at them, even though this graph makes it look like it. It's just a ring-formed parasite. It looks like an engagement ring. Look at the second one. That's what they look like inside of the red cell. This middle stage, all of these are spores. These are getting ready to explode and spread the malaria to other red blood cells. You're not going to see these in the peripheral blood. If you do, it's too late. The patient is on the verge of death. These bottom ones, the gametocytes, these are male and female. which is different from a lot of the parasites we've talked about. You can't really tell them much apart, except this one. Plasmodium falciparum has that very unique, distinct, banana-shaped gametocyte. And you can see that. But like these two, you can't tell these apart. This one's a little bit different to me, especially when you see it on a smear in a second. It kind of looks like a Pac-Man ghost. So that one you can tell a little bit different. You remember how in blood bank, we said that someone who is negative for the Duffy A and Duffy B antigen has a protection from malaria. The one they're protected from is right here, Plasmodium vivax. If you're Duffy A and Duffy B negative, you're immune to Plasmodium vivax. You're partially protected from these other two. The last one, Plasmodium ovale, they don't care about your Duffy status, it's going to infect you. So it's, that's a partial immunity that we talked about. You are immune to Plasmodium vivax if you're Duffy A and B negative, and that's why it's so prevalent, especially in West Africa, to have that blood type. So the Plasmodium life cycle, mosquito bites an infected patient. The Plasmodium spreads and grows in the salivary glands of the mosquito. They bite the next person, and then it spreads throughout the body to the liver and eventually back to the bloodstream. That's why in the Far East and Africa you see those mosquito nets everywhere. So the first stage, the trophozoite stage, is the ring forms in the blood cells. And like I said, they look like engagement rings. If it's a true malarial infection, they're not terribly hard to find. We have, like the slide we have in the lab, has got to be the weakest malarial infection in the history of the world, because you got to look for them. But most of the time, they're like this. I mean, this is a very small field. There's 3 right there. This is the one you're not going to see. And if you do, it is a very poor prognosis. I mean, it's too late. They're gone. You start seeing this in the peripheral blood, they're gone. And then the last one is that the sexually mature stage. And it's the Plasmodium vivax that has what they call the Schuffner dots. That doesn't look like dots to me, it just looks a little bit grainy. Maybe on a better microscope, better picture, maybe you can see the dots. You don't need to diagnose it based on that. Plasmodium vivax, if you see that schizont stage, the bad stage, it will have between 12 and 24 of the merozoites, think spores. This is the one that will very rarely infect someone who's Duffy negative. This is the one you're immune to. Is it possible? Yes, but exceedingly rare. You're protected from malaria from this one if you're Duffy negative for the most part. Falciparum, again, the ring forms don't look much different. You see a lot more of them on this. You may see multiples in each cell. But if you see the gametocyte, this one you can tell the species apart. It has that very unique, very distinct, banana-shaped, mature form. The banana-shaped gametocyte. This one will develop in the vessels of the internal organs. This likes to mature in the blood vessels going to the liver, the kidneys, the aorta. It likes to live in those big vessels internally. But of course, it will spread throughout the blood supply as far as these ring forms. That's just where it likes to mature. This is the one I said, when you see an actual picture of it, Plasmodium ovale, the trophozoite stage. It looks like a Pac-Man ghost to me. It's a little bit unique. So you can tell that one because it's banana shaped, and this one looks like a Pac-Man ghost. It has the frilly bottom edge over here. It only has one big eye, but that one is a little bit different to me. So all of these, if you see ring forms, as far as we're going to get, You see a ring form in a red cell, you're gonna say the patient has malaria. They don't even try to break down species in Africa where it's so prevalent, most of the time, because it's too expensive and the treatment is the same for all of them. So what we wanna see is when we see those engagement ring forms in the red blood cells, we're thinking malaria. There's a problem. Babesia, spread by ticks, endemic in Arkansas. Look at the red blood cells. It has ring forms. If you look around though, it will also have these tetrad forms, these bizarre forms. Plasmodium species will not do that. So if you look around far enough and you see that, now you can differentiate Babesia from Plasmodium. And another thing to keep in mind, Babesia is not terribly rare in Arkansas. Malaria is terribly rare in Arkansas, but not unheard of. There's 7 or 8 cases a year in Arkansas, according to the health department. So it does happen. So you may see either of them, but you're far more likely to see Babesia. It is very easily confused. And here's the best part of Babesia. It is spread by the exact same tick that causes Lyme's disease. You can actually be co-infected with Babesia and Lyme's disease at the same time. Wouldn't that be a fun couple of weeks? But again, look around and look for these tetrads or these Maltese cross forms in the red cells, and that will point you the right direction. You're dealing with Babesia, not malaria. And if you see a ring form at all, the first thought in your head in Arkansas should be Babesia. Excuse me, not malaria. So let's say you look and look and look and look and look, and you don't see anything but ring forms. You never see that tetrad form. What do you tell the doctor? You tell the doctor, we got to send this out. We don't diagnose parasites anyway in Hot Springs. A couple of labs in Little Rock do. You're going to send that out. There are molecular tests to differentiate if you're not sure. But you could tell the doctor, we have some sort of intracellular parasite. I can't differentiate the species. We've got to send that out. The treatment for Babesia is not terribly different than the treatment for malaria. The doctor looks at it, especially like the doctor that I had that day that came over to the lab when I told him something weird was going on and looked at the scope. He can start treatment right there. We can figure out the ID later. And that's what he did in this case.
Question.
Yes?
Just to review, the first picture, there's a lot of crenation happening there. Is that true?
Yeah, there is.
Okay.
A lot of created red cells. This is probably looking at how blue that is and all that. That's probably a very old slide they took that picture from. Yeah, those red cells look a little funky. But you can see, especially like this one, I mean, that looks just like the ring form of malaria. So the next ones we're going to talk about are the coccidias. Number 1, you cat owners. You nasty, nasty people. This is what you get. Toxoplasma gondii. The definitive host in this is the common house cat. Not terribly uncommon. It is, the cyst comes out in the feces, goes into the litter box, hopefully. But it can also be spread to a mouse. That's where it's more important for us, because most people don't change their litter box and then go eat a sandwich without washing their hands. But it can get in the common house mouse. The common house mouse runs all over our kitchen, chews on our loaf of bread, we eat it, we didn't see the hole in the bag, etc. That's how you can pick this up. It comes from your cat. That's not necessarily where you get it from. It also says that pork, lamb, and chicken can be intermediate host, and you can undercook those and get it as well. But if you're looking at the smear, and you look at these, what they're calling tachyzoids, the mature forms, what does that look like to you? It looks a lot like leishmaniasis. It just doesn't have that flagella on the tail. look at those, remember that in your head, and let's go back. It looks a lot like that. But that one has a flagella on the tail. This one does not. Everything else we've looked at that looks similar to this has some sort of a flagella. These don't. And that's how you can tell them apart. Is this common? Among cat owners, it actually is fairly common. This is something you very well may see. The symptoms of this, and the reason it's undiagnosed, is almost identical to the symptoms of mono. Sore throat, cough, fever. The only time it's really significant, this is usually non-life threatening, but if you're pregnant, these can cross the placenta. We talked about a lot of these parasites, and most of them are too large to cross the placenta. This one can. If it does, retardation, blindness, and death of the fetus. That's the three most common outcomes, none of which are good. So normal people, it's going to make you feel awful. If you're pregnant, it can have severe consequences. As I mentioned, seeing this in the blood. The unique part about this can, since it's so small, if it's small enough to go through the placenta, it can go anywhere. This can be seen in virtually any body fluid. Urine, pleural fluid, acetic fluid, spinal fluid. These things can go everywhere. They just swim at free will throughout the entire body. If you think about it, that's a monocyte. That's our tissue macrophage. That goes through the tissue, eating up all the garbage. If that can go through tissue, this is a tenth the size. This thing can swim wherever it wants to. So you can see it in any fluid. But what fluid do we look at the most in the lab? The blood. If you're going to see it, that's your most likely where you're going to see it. Cryptosporidium parva. Usually transmitted fecal oral, like a lot of these other ones we've talked about, like a lot of diseases in general. This was first found in the 1970s, when they discovered it. There was an outbreak in the 80s in Georgia from the local water supply, causing 13,000 cases. There were 3 outbreaks in the 90s. Apple cider, restaurant prepared chicken salads, and green onions. In normal, healthy people, it's self-limiting. It's going to cause extreme diarrhea that will last anywhere from 2 weeks to 2 months. In our immune-compromised populations, it is often rapidly fatal because they can't deal with 2 months of diarrhea. We're talking about the HIV positive, our cancer patients, our very elderly, our very young. In the fecal smears on this, that's done with a Kenyan stain, which we know that's for TB, right? So that was found by accident. On our stains, when we're looking at fecal smears or whatever, they're going to stain this purplish red color. They really stand out a lot in a stool. Compared to the next one, Cyclospora, look how much more orange that one stains. That one compared to this one, it's that much dark, deep purple. So that's how you can differentiate these two, is by how they stain, because they're going to look very similar. This one is a little bit larger, staining differently, causing similar symptoms. Self-limiting diarrhea, usually lasting 2 weeks to a month or so. Not a problem for most healthy people. It's our least healthy populations that we're concerned about. Again, cancer patients, HIV, the elderly, the very young. But based on appearance, if it was unstained, you could not tell these apart, even though this one is slightly bigger than the other one technically. But based on color alone, that deep reddish, almost a purple color versus this bright orange. This one, very similar as far as outbreaks. foods, waters. Fecal oral route. And the last one we're going to talk about. We've already covered this once before, if you recall. This one is now classified as a fungus. So why are we talking about it now? This used to be considered a protozoa because it has such a weird life cycle for a fungus. It has the trophozoite, the pre-cyst, and the cyst stage. And that's why for so many years they thought this was a protozoa. It followed the same life cycle of all these other protozoas. Once they started figuring out how to do DNA analysis and all that, they figured out this is not a protozoa. This is some sort of a fungus. And that's when they figured this out. This is actually a recent change. Pneumocystitis, now classified as a fungus, causative agent of atypical interstitial plasma cell pneumonia. Inhabits the lungs of many mammals, transmitted through respiratory route. Caridiae found in rats, Girovecci found in humans. This is another one that normal, healthy people, any of us in this room get this, we're fine. Are immunocompromised, it can be rapidly fatal. If you get someone who's already immunocompromised and they get this stuff in their lungs, we've already discussed how bad fungal pneumonia is. This is the worst of the bunch. And at that point, this gets like an advanced age patient and this gets in their lungs, there's nothing you can do for them at that point. You're never going to stop it in time. This is one of the primary opportunistic infections of age patients, and this is usually what takes them out. This and TB, that's the two big killers for advanced age patients. End of lecture. I got it on the first try. All right, so Thursday, we're going to review this again before your exam next week. We're going to review it Thursday. We're going to go into the lab Thursday and pull the slides on all this. We've got slides on almost all of these parasites. We've got the digital microscope where I've already taken pictures of a couple, especially the hookworm, because Britt hates that one. The hookworm slide we've got, he knows where it is. I can't find it. There's one egg on that slide. So I made him find it, and we took a picture of it on the digital scope. I'm not going to make you find that one. But the rest of them, we're going to break out the slides, find it on your scope, call your neighbors to look at it, because you're all going to have different slides. That's kind of how you're